Hey guys, how are you? Welcome back to the channel. Today is day 46 of upskilling myself, and today I solved two DSA problems, and one of them was a hard problem. As well as I did some revision of OOPS, AWS, and JavaScript, and yeah, I also had some internship work to do. So let's see the DSA problems that I solved. So the first problem is palindrome partitioning. So we have been given a string S, partition S, such that every substring of the partition is a palindrome. Okay, and we have to return all possible palindrome partitioning of S. Okay, so if this in this case, if you see AAB, AAB, so this is the first substring A, which is a palindrome. Then AA is a palindrome, but AB is not a palindrome, so we will not include it, right? And we have to give our output in such a format that we have to create substrings. We have to create the partitions. When we create a partition for a element, we have to create the same partition for other two elements and add it into the same array. Okay. So how to solve it? So we can solve it using backtracking because there is all possible palindrome partitioning. So we define answer vector or vector strings, then we define output vector or string, then we solve, we call the backtracking function where we pass the string, the answer, output and the index which is 0 at first, then we'll return the answer. So this is the function to check the palindrome, it's pretty basic. Then this is the backtracking function. The base case is that if the index is equals to the length of the string, then we'll push back the output in the answer and then we'll return. Then we'll traverse from I equals to index to the length of the string and I'll be incremented. If the substring is a palindrome, then we'll create a current string which is the substring of index I minus index plus 1, and then we will push the current into the output array. Then we'll again call the backtracking function where we'll pass I plus 1 and then we'll pop back. You can also say you add, you recurse, and you backtrack. Okay. So the second problem is n queens and it's a hard level problem. I don't know if you can see the question, but the n queens puzzle is a problem of placing n queens on n into n chessboard. Okay, so it's nothing but we have been given a chessboard of size n, and we have to place the queens in such a format that the queens do not attack each other, right? So if you see, this queen does not attack any other queen, even for this, this, and this, and same for this board. So we have to return these two boards, right? In the case of 4, the n may be 5, n may be 6, it doesn't matter. Okay, and this is the input format. So the input is n is equal to 4 and the output should be in this format. The output should be in vector of vector and string format. Okay, so how to solve it? First of all, we create the answer into this particular format, vector of vector string. Then we create a board which is the current board of type vector string, where we'll pass the size of the board and then we'll assign every string with a dot value, which means currently it's empty. Okay, then we'll define row as 0 because we want to set queens on the rows, not based on columns. First of all, we'll start by rows. Then we'll call this backtracking function. We will pass answer, board, n, and row, and then we'll return the answer. Okay. Now there comes the main backtracking function, which is n queens. First of all, the base case is if the row is equals to n, then we'll push back the board into the answer and we'll return. Then we will traverse from j is equals to 0, which is column is equals to 0. The column is less than n, so we'll traverse the columns and we'll increment j. Now we will check, is it safe to put the queen on this row and this column on the board. If it is, then we will add the queen into the board on that particular row and column. Then we will call the recursive function and then we will backtrack. That means we'll set it again as empty. Okay, so how to check if it's safe or not? So this is the function for it. We have to check for vertically, left diagonally, and right diagonally. We don't need to check horizontally because we are always incrementing rows over here, so row won't be an issue. So for vertically, we have to check in this manner over here. So we have to just reduce the row and we have to check whether it's Q or not, right? Then for left diagonally, we have to check in this manner. So where I will be also decremented and J will be also decremented, right? And then we'll check for Q. For right diagonally, the rows would be decremented because we are going over here. Rows will be decremented and the columns would be incremented. So I is decremented, J is incremented, and then we check for Q. If in any of these case, if we find Q, we'll return false, else we'll return true. The approach part was difficult one, but when you understand the approach, the coding part was on the easier side. Then for development part, I did some internship work, I did OOPS revision, then I also did some JavaScript revision and did the revision of all the problems that I solved till now. So thank you guys for watching and see you on day 47.